All right, hello again. So in this video, I'm going to go over dictionaries in Python and how we can use them and access them and do basic things with them. So once again, this video is going to repeat a lot of examples from the course text, but I want to explain and demonstrate them verbally so you can get a sense for how these things work. All right, let's get going. So a dictionary is a set of values similar to a list. So they're like this list, and they are the set of values. However, in a dictionary, each value in that dictionary is given a unique key, which you can think of as like a label or almost like a variable that's used to refer to that value in the dictionary. So for example, we had lists we talked about previously. So I might have a list of ages of how old people are. I could have an ages list that has three values, 42, 35, and 13. If I made a dictionary version of that information, I could have an ages dictionary that contains the same values, 42, 35, and 13, but each of those values I've then now given a key. I've given a label to, so that 42 is now labeled as Sarah, the 35 is labeled as Amit, and the 13 is labeled as Zhang. So that way I can be able to basically give, again, sort of these labels to these different values. We end up using these values, these keys, to look up the particular values in the dictionary. So I would be able to talk about the Sarah element of the dictionary, which may have a value of 42. I could look up the Amit element, which is 35, and the Zhang element, which is 13. So in many ways, this works similar to a list, but instead of talking about sort of which index, which value I'm at a particular number, am I the first, second, or third element of my list, I'm going to talk about which key element am I of a particular dictionary. So as you can see, the syntax that we use for dictionaries is to write that we write dictionary literals using curly braces. So these are not, so square brackets are for lists, parentheses are for tuples, and curly braces are going to be for dictionaries. We're going to write out curly braces. We're then going to put in the key, which is going to be usually a string, but can also be a number or tuple. We'll go over that in a second. Followed by a colon, so not an equal sign, but a colon. We have to be very careful about that. Followed by the value that we are assigning that we are applying that key, that label to. Followed by a comma, and then you've got the next element. So again, you can almost think of it as writing a list, but instead of you're replacing the square brackets with curly braces, and you're adding in this key colon in front of each individual element. We can have a bunch of these different kinds of examples. So there's a couple of extra other kinds of dictionaries. I might have a dictionary that's literally like a real world dictionary that converts from English to Spanish. So I could say, give me the English word as a key, and that then refers to then the Spanish version of that word as a value. So then I have key, value, second element, key, value. I can have a way of use dictionary as a way of converting from, say, like numeral numbers to strings. So I might say that the key 1 refers to the value O-N-E, right, to that string. The key 2 refers to the value T-W-O, and the key 3 refers to the value T-H-R-E-E. And of course, I can define an empty dictionary if I need to. Great. So the important thing to note from these last examples is that dictionary keys can be really of any hashable type. So they can be, for us, that means they can be strings, they can be integers, or floats really, but that's really, really rare, or they can be tuples. In practice, almost like 95% of all the keys that you're going to use in dictionaries are going to be strings, so we're generally going to use those as our main key, but it's possible to use something else as well. The other things to note is that keys will have to be unique. Dictionary values, on the other hand, can be any type, right? Dictionary values can be a string, they can be a number, they can be a tuple, they can be a list, they can be dictionary, they can be Boolean, they can be any data type that we've already worked with. So here's an example where I can then say that here's where all my keys are strings, but the values are different types that I want, right? An int is a 12, a string is dog, and a list is 1, 2. On the other hand, I can have a string as a key, which then says that its value is a string, and I can have a tuple as a key and says that its value is of the type tuple. It's all the keys in your dictionary have to be unique. You can't have the two different values that both have the same key. Keys are sort of these unique labels. They're identifiers. They're like the name for that particular value. So if I tried to define myself a dictionary, which said that had an A key, a B key, and then another B key, if I actually go ahead and define that, I won't get an error, but Python will do is it will basically say, well, you can only have one B key, so it'll grab the later one. If you try adding a new element that's a key or trying to change a key, you're going to have to basically say you can only have one instance of each key inside of a dictionary. That said, you can have lots and lots and lots of different copies of the same value. So I can have a dictionary here that has 3 keys, A, B, and C, but all the values are 1s because I can have the same value repeated over and over again. So it's like you can have lots of different, so for example, we go back to sort of the ages example, we can have lots of different people, lots of different names that all have the same age, but I can't have 2 ages associated with that one name. Cool, where are my minutes? So the other thing that's sort of really important to note that can trip up you occasionally is that dictionaries, unlike lists, are unordered, which means that no matter what order you write those keys in when you're declaring the literal, right? If I put A or B then A, it doesn't matter. From Python's perspective, those are the exact same dictionary. It may print them out with the keys in a particular order. It'll often try to sort of match what you gave it, but the fact that it printed out in that order doesn't act, it's just really just a display property. It has nothing to do with the actual data that's being stored itself. Dictionaries have no order. You can't talk about the first key, the second key, or the third key, because all these keys are just sort of their own names. It's almost like if you think about this, if you go back to this hotel metaphor that we've used for lists, you can think of this as sort of like our hotel, but instead of having room numbers, we can't talk about like one room right after another, but each room number instead just has a plaque. It has this name on it, right? What's the label, the key that I'm giving for that room? And if you can more sort of imagine all the rooms are like in a circle, they're all in a giant mess, so there's no way of basically putting them in order. You just have to refer to which person, which room do we actually care about and going to. Great. So overall, what this ends up meaning is that dictionaries act as a data structure that's referred to as a kind of map. And you can think of map like almost like a treasure map, right? It's a map that tells you how to get from one place to another. Technically, it's drawing off the mathematical term for mapping, but we can think of it in the linguistic way, and that works just as well. So in this case, a dictionary is a map, and then it basically says that here it's got this set of the set of things, these keys, and each key basically gives you directions. It tells you how to get to a particular value in that dictionary. So if I have a dictionary here that's going to be a person who has a first name key, a last name key, a job key, a salary key, and a union key, which then have their associated variable values in it, the dictionary effectively provides a mapping that says that if you give me this first key, this first string, I'm going to basically be able to then lead you to the value associated with that ADA. If you give me the last key, the LAST key, I can then lead you to a value that's associated with, which would be Jones. And this is what basically lets your dictionaries act kind of like real-world dictionaries, where you can then say, let me take in the definition, right, the key, and then I can link that will point to, it'll tell me how to get to the actual definition, this larger value that's the thing that I actually end up caring about. Great. So overall, what this ends up meaning really is that these dictionaries are thought of not necessarily as, you can think of them as sort of a set of items, those items each of which have a key, but it's also in some ways more accurate to think of a dictionary as a set of key value pairs, where basically we have a grouping of things, right? I have the key and I have the value as sort of one chunk, one element of my dictionary. The key says what's the label, the value is what's the actual value that we're involved with, but those things put together end up creating the elements of these dictionaries. All right, let's talk about how we actually use these dictionaries more reasonably. So similar to lists, we can access dictionaries using bracket notation. So if I declare myself a dictionary here, so I'm going to have my ages dictionary with Sarah, Amit, and Zong's ages. If I can print it out, you can see that it prints out something that looks similar, looks like a dictionary. The order doesn't matter, but it prints out in the order I gave it, because that's how Python's trying to be nice. We can access these using bracket notation the same way we'd access elements in a list using bracket notation, where I'm going to put in the name of the dictionary, ages, followed by my brackets, and then inside those brackets I'm going to put the key that I want to access. So rather than trying to say go to room number 1 and putting a 1 in there or putting a 0 in there, I'm going to actually put in the key, the label that refers to which value I want. So if I say get me the Amit the value associated with the Amit key for ages, right? Remember that Amit is my key and his value, his age is 35. If I can run that and print that out, I'm going to get 35. I can do something very similar for Zong here. So I can then say access the Zong key, print out that, and that'll give you 13. And that'll basically work the same way as it does with lists, except we're putting in the key instead of a number. I can't access if I try to access a key that's not in the dictionary, so if I try to say get the age of Anonymous, There is no anonymous key in here. All I've got is Sarah, Amit, and Zong. So if I try to access that, this will actually produce an error. I'm going to get what's called a key error. And then what it'll show is it'll say that it'll basically say that it's a key error, right? There was a key that wasn't there, and I had an error accessing it, and the key I tried to access was anonymous. And that's how we'd read this error message. You would actually get something, I'm thinking on the fly, you'd actually get something very similar if you try to access, say, the 0th element of your ages. Again, I'm going to get a key error because there is no 0 key, right? There's no key that's 0. There's just a key Sarah. So we can't access elements by their index because there is no ordering. These are unordered sets. Okay. Also, again, similarly, if I try to access a value, if I try to look up something by a value, so if I try to say, hey, who has an age of 42, I'm going to once again get a key error because, again, 42 isn't a key. 42 is one of the values. The only things that I can put inside the brackets are going to be these keys, Sarah, Amit, or Zong. I can't put 42, 35, or 13 because those are the results, right? I can't say go immediately to there. I have to say start at this location, start at these keys. That's what I can put inside of there. And then finally, just like values and lists, once we've accessed a particular value, we can use that in any kind of expression or any kind of function that we want. So I already up here did an example of how I could say assign it to a variable. I could print it out directly. In this example, I'm going to say let's take that age, because that thing is going to be a number, I can compare it to 18, and then take that Boolean result, assign it to Zong is old, and then I can print out whether that's true or not. And if I run this code, then I ask whether Zong is old, and the answer is false, because again, his age, which if I go look up ages of Zong, is go ages, go to the Zong key, and that value is 13. So if I replaced a 13 in here, right, so effectively this is implicitly doing that work, right? I'm saying that the 13 is greater than 18. That's a false statement, so I get false back. Done. Great. Okay, also similar to lists, we can use bracket notation in order to assign new values into my dictionary. We can use it to modify, to mutate the dictionary's values itself. So for example, if I have my ages dictionary again, I could say assign a new value to the Sarah key by saying go to the ages hotel, right? Go to the Sarah room. I'm not going to the first room or the 0th room, but go to the Sarah room, and then we can assign a value of 45. If I do that and then I say print out what is Sarah's age, we'll be able to see that Sarah is now 45. If I also went ahead and printed out just the ages entirely, you can see that now I have my whole dictionary where Sarah is 45. We can do something similar to say, like, if I want to assign a value, I want to access and assign a value based on itself. So for example, I could say, let me go get Amit's age. Amit's age was 35. When I add 1 to that, that's 36. So I can then take that 36 value and assign it back to ages of Amit. I run this as well, and now you can see that Amit has also aged a year. Sorry, aged 3 years. I'm not sure how that happened, but Amit has aged 1 year. And so we can basically do the same kinds of things we did with lists. Again, we're able to modify the values in an existing dictionary. This is not creating a new dictionary. We're going to just sort of modify what already there. We're going to put different people, have different people move into the hotel. The thing that is different, though, with dictionaries from lists is that we can actually use bracket notation to add new additional keys to my dictionary. I can actually try to assign and create new rooms in my hotel. Because there's no ordering, because there's no sort of set sizing for the hotel, I can do this in order to actually add new elements. So for example, in my ages, I've got Sarah, Amit, and Zong. There is no Fred key. So if I try to access ages Fred, if I try to print that out, I would get an error because it doesn't exist. However, I can actually assign a value to that key. And what that will do is that the Python interpreter will go to, because I'm assigning a value, it'll go to ages. It'll say, do I have a Fred key? I don't already have one, so it'll actually create a new key and then add this value to that dictionary. So if I try to say take 23 and assign it to the Fred key of ages, and then I print out ages, what you'll see is that I now have Sarah, Amit, and Zong as I had previously, and now I also in that same dictionary have a Fred value, or I have a 23 value whose label is now Fred. So we can actually do this to be able to add additional values into a dictionary. There's no requirement that the key doesn't have to previously have been created. If you want to, say, add a new element to a dictionary, you just go ahead and give it a new key and then assign that directly. So you can go ahead and whatever values you might want to add to the dictionary, you just go ahead and assign to them and they will get added in. A new room gets built in the hotel. This is different from lists. In lists, you have to make sure that you've got things there in the first place, or have to use the append function. But in a dictionary, you just assign to the room you want it to be in, and that will create the room. It gets added into this mystical space where we have a bunch of rooms that have no ordering. All right, so dictionaries support a number of functions, a number of methods, the same way that lists support a lot of methods. You can look at these all in the documentation, and there's sort of a number of these different things that all do different stuff. There's not quite as many as there are for lists, but they kind of exist anyway. In practice, we don't end up using a ton of these methods for dictionaries. Unlike lists, where that append method is really, really important because it's the piece that it's what we use to add new rooms to our hotel, right? It's what we use to add new elements to our list. With dictionaries, because we don't need that appending method, we can just assign directly, we end up actually not using a ton of these methods. So I'm not going to go over all of them in a lot of detail, except for one. And there's one that's really valuable, and that's this get method. All right, so let me show you how this works. All right, so we're going to go back to our ages list. So I'm back to ages. I've got Sarah, Amit, and Zong, right, our three values. As I mentioned previously, if I try to access a key that's not there, I'm going to get an error. So if I try to say get Alice's age, and again, there is no Alice key, if I try to do that work, I'm going to get a key error because there is in fact no Alice. So what we can use the get method to do is to effectively say, let me try to access a key, and if that key isn't there, rather than having the interpreter produce an error, rather than having it crash and not work, we're instead going to return a value of none. So the way this would work is instead of saying I want to access the Alice key by using bracket notations, I would say I'm going to call the get function method, and I'm going to pass in which key I want to access. I'm going to pass in that I want to get the Alice key. This value will then get assigned to Alice age. Now remember, Alice does not exist in the dictionary, right? We only have Sarah, Amit, and Zong. But when I say get Alice, rather than producing a key error and saying something breaks, what the interpreter will do is to return none, so that Alice's age is now none. There is no value. And that kind of makes sense, right? Like if we go to the dictionary and I say, hey, Alice, what's the age of Alice? We say, well, none, because there is no Alice thing, so we get nothing back. So the get function will let you access values, but without having to worry about getting an error, right? Because if the key doesn't exist, then you're not going to get an error along the way. That makes get fairly useful. It's not, in practice, we'd often like to use bracket notation if we can, just because it tends to be a little bit faster, a little bit cleaner. It's sort of more idiomatic and standard. But this get function will let us be able to deal with if I'm not sure whether that key may or may not exist in the dictionary. Great. But wait, there's more. So by default, the get func method will return none if the key doesn't exist. But maybe I want to get something different. Maybe I want to say, okay, get the Alice value. But if Alice is none, but if Alice doesn't exist in the dictionary, I don't want to get none back because none's not a number. I can't do anything with none. Maybe I'd rather get 0 back as a default, right? So if that person is not in the dictionary, let's say their age is 0, rather than saying their age is none. And the way we can do that is by specifying a second argument to the get function. So I'm going to say that I want to get the Alice key, comma, the second argument is saying that I want the default, the value I want to get back if Alice doesn't exist should be 0. So now what will happen is the interpreter, as I'm going to call ages.getAlice, it's going to go to my dictionary. It's going to say there is no Alice, so it's going to give me 0 back. And when I do that, I then, instead of getting back none, I now get back 0. If, on the other hand, I went and looked for Sarah, so I said get me the Sarah key. I'm just going to change the variable name so it all makes sense. This would say, go get me the Sarah key. If the Sarah key is there, give me Sarah's age. Otherwise, if Sarah doesn't exist, get me a 0. And when I execute that, then you can see I get the 42 because Sarah does actually exist in the dictionary. So this get structure lets you be able to, again, to effectively get around errors if you don't know if something's in the dictionary or not. This only happens some of the times. If you know it's in the dictionary, like you know that you're trying to access a particular key, like I know Sarah is there, I've been very careful about how that's put together, then bracket notation works great, but this will let you get around that a little bit. This kind of thing ends up becoming really useful, particularly when you end up working with functions and we don't really know what we're working with. So for example, here's a really basic function. This is my isold function again. And I can say isold, or just asking if, once again, if Zong is old. If not. So the way this is going to work is I'm going to call the isold function. I'm going to pass in Zong, right? That's my name. I'm then going to take that key that got passed in. I'm going to access that key from my ages dictionary, save that as person.age, as the person age, and I'm going to compare that person age to 18 and return the Boolean true or false. So if I pass in Zong, this works great. It tells me that Zong is not old. That's a false statement. On the other hand, if I ask about Sarah, Sarah is old because she, yeah, sure, is over 18. The error here then, if I then say, well, is Alice old, right? I get my key error, right? Because remember that I can't put my Alice inside of this ages bracket because there is no Alice. So they're at, you can see that at that point, when I try to access ages name, that's where my little arrow is, I end up getting this key Alice, error Alice. So what I would then do is I can say, okay, great, well, I don't know what values are coming in. There might be some names that aren't in my dictionary, so I can replace that with the get. Right, so I'm going to say rather than trying to access with bracket notation, I'm going to access it using the get method. So I can do that exact same work. I then run that code. Now I'm not getting that error, right? I've gotten past line 2. My error is now at line 3. But now I'm getting another error where I'm saying that, well, I can't compare the greater than symbol. I can't say if none is greater than 18 because none has no value, so there's no way of knowing if it's bigger or smaller than 18 or not. I could try to fix this by using some kind of if statement, or I could say, well, if person age is none, then do something else, but that ends up getting like really long, complex, and sort of annoying. I'd rather be able to just be able to say, I also want to take that age and I want to compare it to 18. So here's where I could say, okay, great. Instead of having a default, having that default value for missing ages be none, I can have that value be 0. And now I'm able to ask if Alice is old, and the answer is false because Alice isn't in there. Done. And that's the idea of how we can use this get method. It's generally very useful. Again, if you aren't sure what's coming into your dictionary, this tends to be if you're creating your dictionary by reading in files, or if you're trying to say get user input, get ends up being really useful for basically being able to handle this without having to deal with a ton of errors along the way. Okay, as I said before, dictionary values can be of any data type. They can be strings, they can be numbers, they can be tuples, they can be lists, they can be other dictionaries. And so I want to show an example of the sort of more nested, complex dictionary structure. So here's an example of a dictionary that's representing a particular person. So I'm going to say that here's a person variable, right? There's my variable declaration name. I'm assigning it a dictionary, and you can tell it's a dictionary because it's got these curly braces starting it. I've added in a bunch of extra white space just to try to keep it more readable. You'll notice that if I print out the person at the end, then Python can still print it all in one line, and it looks kind of the same, right? We have a dictionary who's got a first name key of Alice, a last name key of Smith, an age key of 40, a pets key whose value is a list, right, with 3 strings inside of it, a favorites key whose value is itself a dictionary with 3 other keys inside of it, one of whom is a key whose value is then a list. So person has 1, 2, 3, 4, 5 keys. Person favorites has 1, 2, 3 keys. So we can be able to start trying to access these kinds of things, right? So I could say, great, let's take my person, and I could try to access my person's pets key, and my person's pets key is then a list. I could take my person and I could access their favorites key, right? And this could be, let's assign it to a variable. We'll call this favorites. Print out. Right? So there's my person's favorites key, which is itself a dictionary with 3 values, music, food, and numbers. Which means, of course, I can take favorites and ask for this person's favorite food, which is pizza. But again, remember, because that favorites is itself a value of person favorites, it means that I could take this person favorites piece and I can replace that with my with the expression they gave in the first place. This is similar to how our nested, our 2-dimensional lists worked previously. So I can say, great, go to person, then go to their favorites key, get that value, and then from there, go to their food key in order to get that value as well. And when I do that, then I once again get myself back to pizza, right where I expected to be in the first place. Similarly, if I go to person's favorites and then I go for their favorite numbers, then that's going to be a list, which means I can then say access the 0th element of that, get their first favorite number, which could be 12. I can take that person favorites numbers in order to then say append a new value. Let's say we can add 7 as another favorite number, so that then if I go ask for person favorites numbers, then now there's 3 values inside of there. So again, we can end up using, with these sort of nested complex dictionaries of dictionaries, we can end up using the same sort of pair of bracket notation that we used when we had lists of lists. In this case, we just happen to have lists, or I have a dictionary of dictionaries of lists, as opposed to having a list of lists potentially. Good. It's also worth noting, of course, you can assign values in dictionary, new lists or new dictionaries to a dictionary, existing dictionary. So if I take my person, I can say give them their luggage combo key, and I can assign that to be a new list, 1, 2, 3, 4, 5. If I then print out what person looks like, then we can say, here's my person. They now have a luggage combo key that has a list inside of it, and you can see their numbers have updated, and all these things have come together. So this kind of dictionary representing a complex value, right, where I have a dictionary that represents a person, has all these different attributes, some of which are themselves other dictionaries, is fairly common in some kinds of data analysis. It tends to be a little bit more common to use something like a class, which we'll discuss in a different lesson, in order to do some of this kind of modeling work. But this will at least, it shows up periodically, particularly if you start trying to access like existing data sources on the internet, then you might get something that ends up looking a little bit like this, depending on how complex your data schema ends up being. So the other common way that we're going to combine lists and dictionaries together is to create a list of dictionaries. In particular, if we set it up so that each dictionary has the same keys, so not necessarily the same values, but the same keys inside of it, then they can actually use the structure to represent a data table, to represent the kind of thing you might find inside of a spreadsheet or inside of any kind of thing you might want to do some data analysis on. So here's an example where I have a people variable, which is a list. We can tell it's a list because it has the square brackets. And then this list has 1, 2, 3, 4, 5 elements inside of it. Each one of those elements is then a dictionary. And each of those dictionaries has a name key, a height key, and a weight key with then different values assigned to them. If we then think of each of these dictionaries, right, each of these elements inside this list as a row, like in a table, then we effectively have a list of rows, which produces us a data table, right? I have a list of rows. I have the Ada row, the Bob row, the Chris row, the Dia row, and the Emma row. Each of those rows then has a name value, a height value, and a weight value. So by putting this together, then we can basically have we have a list of rows, or a list of records, and then each row has a set of columns, or a set of features sort of listed up inside it. All right, let's see how this works in code. So I can have this same code inside of Jupyter. So I can find my people list. I can then print out my people list, see what it looks like, and again, it all gets compacted when we print it out in Python. If I ask how long people is, right, there are 5 elements inside of this because it has 5 rows, even though there are actually like 15 different values here, a bunch of strings and a bunch of numbers. Once we have this, we can start doing some analysis on this list the same way we do analysis on any other list. Rather than having a list of numbers or a list of strings, we now have a list of dictionaries, and that doesn't end up changing that much more. So for example, as a sort of a worked example to go through this, we can take this dictionary, this list of dictionaries, and we can say, well, what are the total weight of all these people? Maybe we want to make sure that they're not going to like sink a small canoe that they're in or something. I don't know. Let's go figure out their total weight. So the way we can think about doing this is the same way we'd imagine if we were trying to add up a whole bunch of numbers in a list, is we'd say, let's come up with a total variable, and then let's loop through the list in order to add in all those pieces. So we could do exactly that. Maybe we'll start out with a total weight value that could be 0 to initially, because we're going to start at 0, and we're going to add in a bunch of the pieces in. Because people is a list, I can loop through it using a for loop. So I might say for each person in the people list. Notice my naming here. People is plural because it's a list. Person is a singular, so it's a thing. That's fine. As I go through each person in my people's list, if I print out that person, you'll see that what gets printed out is going to be each dictionary, right? Person is a dictionary. That's the kind of thing that it is. Once that's done, I can say, great, so because person is a dictionary, I could actually access their value. I could say access their weight key. And I know, because of how I've structured this data table, that each one of these dictionaries has a weight key. So I don't need to worry about using the get method. I don't have to worry about getting errors because I know that they all have that particular key. So I could, for example, go through and say, for those people, let's print out all their weights. Look, there's all their weights, right? I printed out all those pieces. I've now accessed that information. I can then, of course, take my total weight and then have that be my original total weight added into this person's weight variable. or I can just access that value. I don't need to print it out anymore, so I can get rid of that. When I'm done, let's then print out what my total weight is at the end. And it turns out if I add all these people up, then the combined weight of these 5 people is 726 pounds. I have no meaning behind that. There's a bunch of random numbers I put together. But again, this is trying to demonstrate that if I structure this list of dictionaries, I can treat it like a list. I can loop through things. It's just that each thing, each person, each element that I'm going through in that list happens to be a dictionary, so I would access it using this kind of bracket notation. Great. Okay. So finally, where'd it go? There it is. The last thing I wanted to sort of cover, that's our basic idea of how we use lists and how we use dictionaries together. The last thing that I want to sort of make sure to note is there's always a question then of which data structure should I use? So we now have lists, which are our square brackets. We have tuples that are our parentheses, and we have dictionaries, which are our curly braces. So the question is, which do we use for which? I've got a little bit more text about this in the textbook, but the general rule is that you use lists for when you have an ordered sequence of data. When it matters that there's the first, the second, the third, the fourth, and the fifth, or the sixth thing. That may not be important that they're in order, but you want to have them in some kind of sequence. You want to have them in some kind of group so that you can do something with them. In practice, lists are a really good default. If you have a bunch of data and you want to put it into some kind of data structure, use a list. That'll probably work out okay for what you need. You can then, so that sort of should be your default choice, right? Use a list. Then you might say, well, I want this list to be an immutable sequence. I don't want to be able to change those values in the middle. Maybe there's only a couple of elements. I'm not going to be adding new ones to them. I basically want it to be sort of this like hard-coded, like not going to ever change set of data. In that situation, use that for a tuple. Use a tuple instead of a list there. Again, tuples are going to be generally for really small data sets when you have like 2 or 3 or maybe 4 values. You're not going to use them for large complex things. If you think about it, it's like a bunch of data, that's probably a list. If it's going to be like, well, I want to have these 3 things grouped together, that might be a tuple. Dictionaries, on the other hand, are used for mapping data, right? If you want to have your set of values, and you can have a lot of these things, but you want each one to have its own key, each one needs to have its own name. So it's not just that I have a bunch of values and they happen to be in order, but it actually refers to that this value belongs to this key, this value needs to belong to that key, and these things need to have some other way of labeling them together. That's when you might end up using a dictionary. So lists are great for large sets of data. Dictionaries are good for if I want to then have a mapping structure of data, and tuples are sort of that like, well, they're kind of a special kind of list that we use for very small sets of data. So in practice, you should sort of default to going with lists. If you need to end up having keys, you can go with a dictionary, and then if for whatever reason you decide you need a tuple, you can use that.